Let's have a look at this interview question from a quant firm. You have a 30-sided die and I have a 20-sided die. We roll both of them and whoever gets the higher roll wins. If we roll the same amount, I win. The loser pays the dollar amount of the winning roll. What is the expected value of this game for you? Before tackling this question, let's first define the variables. Suppose m is the number you roll and n is the number I roll. There are only two outcomes of this event. You win or I win. The first case occurs when m is larger than n, where I pay you money equivalent to m. The second case is when m is less than or equal to n. In this case, you pay me n dollars. Focusing on case 1 first, the probability of rolling any specific number m is 1 over 30, and the probability of m greater than n is m minus 1 over 20. Of course, if m is greater than 20, then this probability is 1, since the largest number I can obtain is 20. Let w be the function that relates m with the money you obtain in case 1. Wm will equal m times the probability of m greater than n. The expected value for this case, em, will then be the probability of rolling the number m multiplied by the money you earn. Since it is the expected value, we take account of all possible outcomes from 1 to 30 and total them up. We have to be careful here because the probability of m greater than n compiles two functions, so the total when m is greater than 20 must be written separately. When m does not exceed 20, Pm greater than n is m minus 1 over 20. When m is larger than 20, Pm greater than n is 1. By substituting Pm and Pm greater than n, we get these functions. Next, all we have to do is to add these together. By extracting the denominator and multiplying the terms, we get this expression. Before doing any numerical calculations, let's look at the second case, since we are ultimately combining the expected value of both cases of winning and losing the game, and some terms may cancel out when we add the expected values together. Let's focus on the possibilities regarding n, since if you lose, the money you have to pay is n. We know that the probability of rolling any number n is 1 over 20, and the probability of n greater or equal m is n over 20, and of course, if m exceeds 20, this probability is 0, but we only discuss the case when you lose. Let Ln be the money you have to pay when I roll n and win, and Ln will be n multiplied by the probability of n greater or equal to m. Substitute the probability, we get Lm equal n times n over 30. Let En be the expected value you lose, then En will be the sum of n times Pn times Ln, where all values of n from 1 to 20 is incorporated. Substitute Ln, En becomes n times 1 over 20 times n over 30, which simplifies the sum of squares from 1 to 30 divided by 600. After obtaining all the expected values of winning and losing the game, we can find the net expected value E by subtracting En from En. By substituting what we have gotten previously, we get this expression. Note that the first and the last term can cancel out. After simplification, the expression becomes this. Finally, using the summation formula, we can calculate this expression consisting of only numbers, which simplifies to 8.15. Thank you for watching this video. This is only a part of question 9 out of 15 questions of the interview. If you find these questions interesting, let me know in the comments section. I'll see you in the next video.